Hello dear students, Assalamu alaikum. Welcome everybody to my channel GJG Physics Academy. This is Dr. S.M. Abdul Razzaq, Associate Professor, Department of Physics, Shahjatpur Government College, Shahjatpur, Shirazganj, Bangladesh. Please subscribe to my channel to get the new lecture. Today I am going to teach you a very important law of electricity. This is Kirchhoff's second law. Let's get started. Kirchhoff's second law or voltage law. The algebraic sum of all voltage changes around a closed circuit is equal to 0. This is an example of conservation of energy. Kirchhoff's second law is also called loop theorem. For understanding Kirchhoff's second law, we have to know four basic things. Let us try to understand these four basic things with the figures. If we go from a higher potential point to a lower potential point in a circuit, potential will fall. So potential fall or voltage drop will be minus IR. Minus sign represents potential fall. Note that in the circuit, plus sign indicates higher potential point, minus sign indicates lower potential point. Again, if we go from lower potential point to a higher potential point, potential will rise. So the potential rise will be IR and it is positive. And if we go from positive terminal of a battery to a negative terminal, potential will fall or voltage will drop, and in this case potential drop will be minus E. Again, if we go from negative terminal of a battery to a positive terminal, potential will rise, and in this case potential rise will be plus E. Let us now first applying Kirchhoff's second law in a single loop circuit. Let us now first applying Kirchhoff's second law in a closed circuit A, B, C, D, A. When we will go from higher potential point to a lower potential point along AB, potential will fall, and potential fall will be minus IR1. When we will go from B to C, we are going from higher potential point to lower potential point. So potential will be fall, and potential fall will be minus IR2. When we will go from C to D, potential will fall, and potential fall will be minus IR3. And when we will go from positive terminal of battery E2 to negative terminal, potential will fall, and potential fall will be minus E2. When you will go D to A, we are going from higher potential point to lower potential point, so potential will fall, and potential fall will be minus IR4. And when we will go from minus terminal to plus terminal of battery E1, potential will rise, and potential rise will be plus E1. And when we will come back at point A, potential change will be 0 according to Kirchhoff's second law. So sum of all voltage changes is equal to 0. By rearranging this equation, we have E1 minus E2 is equal to IR1, IR2, IR3, IR4. So sum of E is equal to sum of product of IR. Now we will apply Kirchhoff's second law in a multi-loop circuit. This is a multi-loop circuit. Here is three loops. One is A, P, Q, D. Another is P, B, C, Q, and another is A, B, C, D. First, we will apply Kirchhoff's second law in the A, P, Q, D, A closed circuit, and when we will go from uh, from P to Q, potential will rise, and potential rise will be I to R2. And when we will go from Q to D, potential will rise and it is plus E1. And when we will go from D to A, potential will fall, it is minus I1 R1. And when we will come back at the point P, total voltage is equal to 0. This is, and now we will apply Kirchhoff's second law in the closed circuit P B C Q P. And when we will go from P to B, there is no any potential change because P and B are the same potential point. When we will go from B to C, potential will fall. This is minus I3 R3. When we will go from positive terminal to negative terminal of battery E2, potential will fall and it is minus E2. And when we will go from Q to P, potential will fall and potential fall is equal to minus I2 R2. When we will come back at point P, total voltage changes in this closed circuit is equal to 0 according to Kirchhoff's second law. And now we'll apply Kirchhoff's second law in the closed circuit A, B, C, D, A. And when we'll go from A to B, there is no potential change because A and B are the same potential point. And when we'll go from B to C, potential will fall and it is minus I3 R3. And when we will go from positive terminal of battery E2 to negative terminal, potential will fall and this is minus E2. And when we will go from negative terminal to positive terminal of battery E1, potential will rise and it is plus E1. And when we will go from D to A, potential will fall and potential fall will be minus I1 R1. When we will come back at point A, all voltage changes according to Kirchhoff's second law will be 0. That's all.